Here we're going to look at question 16 from section 2 of the ENGAA specimen paper. So in this question, we're told that we have two particles, P and Q, which are separated by an initial distance of 60 metres. Now, initially, P is just stationary, but has an acceleration of 6 metres per second squared, which is in the direction of Q. If we look at Q, then we see that initially it has a velocity of 14 metres per second in the direction of P, but has an acceleration in the opposite direction of 2 metres per second squared. So the question then tells us that these two particles do collide at a time which we've called t here. And it then asks us just to find t, the time the two particles collide at. So if you would like to have a go at this question yourself, then just please pause the video now, otherwise we'll have a go. So to try and solve this question, we should have a bit of a think about what's actually asking us. It's asking us to find the time at which the positions of our two particles are the same. So what we could try and do is find the position of P at some random time, and the position of Q at some time, and then setting these equal to one another, we'll find the time at which these positions are equal. So let's begin by looking at the position of P. Now P is an accelerating particle, which has a constant acceleration. So what can we always use when we have constant acceleration? Well, we could think about using our Suvat equations. So these are going to be really handy because we have a displacement in there, and it also takes into account other things like our velocity and our time, which is what our final answer is going to be looking for. So let's try and think about what each of our variables are going to be. So if we're just trying to find the position of P, then let's just call it some position S. Then we know that since our particle is stationary, u is just going to be 0 meters per second. Our final velocity, we don't know yet. Our acceleration, we were told in the question, is 6 meters per second squared. And the time which we're looking for, we're finally going to be looking for, is the time at which the two particles collide. So let's call that our t. So next we need to try and think of some equation which connects these four variables which we have together. So the one which that's going to be is this, that s equals ut plus a half at squared. Now luckily in this case u is just 0, so that gets rid of this first term. We can substitute in the values which we do know to get that s equals 3t squared. Now with this position of P, we can go ahead and try to find our position of Q too. And then hopefully that will give us something which we can substitute into this equation to make the two equal and find our time. So if we do exactly the same thing and consider each of our Suvat variables, then our displacement isn't quite going to be just s, the same as it was before, because if you remember from our diagram, Q is already a displacement of 60 meters away. So the displacement of Q at the point when these two particles collide is going to be s plus 60 meters, since it's already 60 meters on, or 60 meters away from Q. Now if we go on and do the other variables, then we're told in the question that our initial velocity is 40 meters per second to the left, so we'll take that as being negative. We're not going to know our final velocity. Our acceleration, we're told, is 2 meters per second squared, and the time, just as we did before, we're going to say is the time when the two collide, since this is the displacement which we've chosen. Our displacement of s plus 60 relative to p. So again, we need an equation which connects these four variables, which just is going to be the same as before, s equals ut plus half at squared. Now substituting in these things, we find that s plus 60 is equal to minus 14t plus t squared. So with these two equations now, you can see that we can eliminate s and try and solve for t. So substituting in that s equals 3t squared to the equation we just found, we get this here, which of course we can simplify a little bit since we have t squareds on both sides, and then bring it all onto one side so it's equal to 0, we get a quadratic in t. So all we have to do next is try and solve this quadratic, which we can just do using the quadratic formula. And now while this might look a little bit odd, we will get a square root of 169 in there. So the square root of 169 is a nice one to remember, it's just 13, giving us that t is just minus 7 plus or minus 13, all divided by 2. So this comes out giving us two different values of t, one of minus 10 seconds or one of 3 seconds. So obviously this minus 10 seconds is unphysical, it can't happen, we can't have a negative time. So the answer we want is 3 seconds. So this is going to be our final answer and corresponds with answer B, given in the question.